Hello everyone. Today we are going to discuss the fourth problem of Leetcode Weekly Contest 375, which is count the number of good partitions. So we are given an array nums consisting of positive integers. Now we have to partition the array. Now a partition of an array means that we have to divide the array into contiguous subarrays. Now if it is called good if no two subarrays contain the same number, and we have to return the total number of good partitions of nums modulo 10 to the power 9 plus 7. So let's take the last example and I'll try to explain what are good partitions. So let's take this. So this is our array, right? 1 2 1 3. Now good partitions, let's divide it into partitions, right? What could be the possible partition? Possible partition could be 1 2 1 3. One possible partition could be 1 2 1 3. Another possible partition could be 1 2 1 3, and another possible permutation will be 1 2 1 3. Okay, and there could be other possible permutations like 1 2 1 3, like that. So now let's consider these five partitions first. Now the first partition contains 1 and the second partition contains 1, so these two partitions contains the same number, so this is not a good partition. For the second case also, the first and second partition both contains 1, so this is also not a good partitioning. Now for the third example, the first partition and second partition contains distinct integers, so this is a good partition. For the fourth one, there is only one partition, so this is also a good partition. Now for the fifth case, the first and the third partition contains 1, so this is not a good partition. So the total number of good partitions for this array is only 2, so our answer will be 2. Now let's jump into the constraints. So constraints is in could be at max 10 to the power 9 and 10 to the power 5, and nums I could be at max 10 to the power 9. So our possible time complexities could be like mm, order of in and order of in log n. Okay, order of in or order of in log n. Now let's think about some observations, right? First think about some observations. So what could be the first possible observation? So the first possible observation is that, let's say we are at some index I, right? So what could be the minimum value of the partition starting at index I? Okay, so I hope you got it. Let's say we are at this 1 2 1 3 4 5 1 6 7, right? This is one array. Now let's say we are at some index, let's say um, this index, right? This one, we are at this index. So what could be uh, the rightmost value, like the partition, the minimum partition that could start from 1, right? So we can't take this 1 3, right? Because we have already 1 here, right? We have to take this one in this one's partition, right? We have to take this one into this one's partition. So the minimum uh, length of partition could be 5, like 1 3 4 5 1. Okay, 1 3 4 5 1. Similarly for this one, what could be the length of the minimum partition value? The minimum partition could be of length 7, because we have to take this one. So what we are observing here is that we have to take let's say we are at index I, then we have to take large value of ai as the right point of the current partition. Okay, now there could be some other cases also. That's the one important thing. So let's take this case: 1 2 1 3 4 1 6 2 7. Okay, now you are saying that for this one you are saying that this one would be the rightmost partition value uh, according to our algorithm. But when we are at this partition, you can see that this 2 has the right partition value as this 2, right? So our overall partition will be this one, from this one to this 2. So what we are doing here, the algorithm will be that, let's say we are at some index I and we have found the last of I. Now what we will find, we will try to find the maximum value from I to last I, right? The maximum value of I to last I will be our last of I, right? That's what we are defining. Last of I will be maximum value of I comma last I. So instead of taking this as last, so let's consider this as next. So this will be there are two values here, right? There are two arrays. You might be confused here. So next of ai will define, sorry, last of ai will define what is the last index of ai, right? Now, and next up I will define what is the minimum partition value, minimum partition value, minimum right index of the current partition starting from I. So next up I will be nothing but maximum of next of I comma last of ai, right? This is the value. We are taking the max in next, right? We are taking the max in next array. So for this finding the max from I comma last of ai, we can use some data structure. I have used segmentary here. I think there could be some better data structure here. So our overall time complexity for this problem will be order of n log n. I hope you got it. Now let's jump into the code. It will be much better. So here this is the part for segmentary. We are considering one segmentary which the operation will be max. Okay, so we are taking the max in the segmentary. Now here I have just initialized aim of ai will be nothing but last of ai, you can say. Now we are defining next as last of ai. Now we are taking the next value as maximum of next comma, we are querying over I plus 1 to next plus 1. I have already told we will be querying over I to last of ai, and we are taking also last of ai as consideration, okay, because we will update the segmentary after the current operation. So I hope you got it. You can take from I plus 1, and we are taking also max of last of ai, okay. That's what we are doing here. Now we are updating the value of the current index to next, and our dp of I will be, now this part is interesting. Dp of I means that the number of partitions. Dp of I is the number of partitions starting from I. Now let's say we have found our this partition, right? The partition from this one, let's say this is the partition, right? Has to be right from starting at index 1. Now there could be some other partitions here also, 6 7, or considering the entire thing 6 7. Now this is one partition. Now we can include this bigger partition into the smaller partitions, or we can keep this as distinct and consider this as different partitions, right? So what I am saying, let's say from 6 7 there could be two types of partition, 6 7 and 6 7. Now we have a bigger partition, right? Now what we can do, we can keep this as distinct. So one partition will be this one, this one, this one, or one partition value could be this one and this one, or we can also merge these two. This could be one partition value, and also we can merge this one, right? So instead of what we are saying, that we can keep it as distinct, and so total number of partition will be dp of next, or we can merge this to the first one. So the total number of partition value will be dp of next into 2. That's what I am doing here. So if next equals to n minus 1, that means that we are at end. Our rightmost point of the partition is the end. Then there is only one partition. But if this is not the end, there could be one partition value here. So our total partition value will be 2, because we can take the entire thing, or we can take them as distinct, okay. So 2 into dp of next plus 1. I hope you got it. The dp part, if you have any doubt in this dp part, I think there might be some doubts, you can write in the comment section. I will try to reply each and every comment. The other parts, finding the next and the last, is quite straightforward using segmentaries. You can go through the segment, how I have implemented the segmentary. If you have any doubt in this part also, you can write in the comment section. If you find this video helpful, please like the video and subscribe to my channel. Thank you.